Okay, welcome back. We'll be looking at Module 5 today, plumbing. We're looking at the water supply systems and tank installation, advanced system design, pumping, and hot water engineering. And this module develops full system design capabilities, covering tanks, pumps, piping materials, hot water systems, and concealed leak diagnostics. By way of module objective, the learner should be able to design a complete water supply systems for residential buildings. The learner will understand tank selection, pump sizing, and pipe material decisions based on real-world conditions. In addition, the learner will be able to install and connect water storage systems correctly while avoiding structural and health risk. The learner will also develop the ability to diagnose concealed leaks and recommended hot water situations. By way of introduction, this Module 5, represents the transition into advanced plumbing practices, where the focus shifts from individual features to complete system design. At this level, the plumber is responsible for ensuring continuous water supply, correct pressure, durability, and long-term reliability. This includes selecting tanks, pumps, and piping systems that work together efficiently. The knowledge gained here positions the learner as a professional capable of handling complex residential and light commercial installations. Overhead versus underground tanks. Water storage systems are essential in areas where, with unreliable supply, choosing between overhead and underground tanks affects the entire system design. Overhead tanks rely on gravity to provide pressure, making them simple but limited in performance. Underground tanks provide large storage capacity but require pumps to deliver water to the building. A proper understanding of both systems allows the plumber to design efficient and reliable solutions. Overhead tank installation requires careful structural planning to support the weight of stored water. So the tank must be placed on a reinforced surface and positioned for effective gravity distribution. So proper installation of inlet, outlet, overflow, and drain connections ensure safe operation. Attention to details such as mosquito proofing and access improves hygiene and long-term usability. Underground tanks provide large volume storage and protect water from sunlight and contamination. Installation requires excavation, proper base preparation, and careful backfilling to prevent structural failure. All pipe connections must be tested before burial to ensure costly repairs later. Safety considerations, including ventilation access, are critical in underground installations. So, pump selection fundamentals. How do you select which pump? Selecting a correct pump is essential for achieving reliable water flow and pressure. Key factors include flow rate, head, and system resistance. Understanding these parameters ensures the pump matches the building's requirements. Incorrect pump selection leads to poor performance, high energy consumption, and premature failure. Let's look at centrifugal pumps, the first selection. Centrifugal pumps are commonly used for transferring water from ground tanks to overhead tanks. They are efficient for moving large volumes of water at moderate pressure. Proper installation, including priming and correct pipe sizing, is essential for operation. These pumps are simple, reliable, and widely used in residential systems. The next one we have jet pumps. This is a jet pump. Jet pumps are designed for drawing water from wells and boreholes at greater depth. They use a venturi system to create suction and lift water beyond the limit of centrifugal pumps. Although less efficient, they are essential for deep water sources. Proper sealing and priming are critical to ensure effective operation. Now let's look at selection of pipe. How do you select a pipe? Proper selection of pipe. Selecting the correct pipe is critical for durability, safety, or performance. Each material has specific applications based on temperature, pressure, and cost. Using the wrong material can leads to leak, corrosion, or system failure. Professional plumbers must understand the strengths and limitations of each option. Let's look at the first, or let's look at both of them together, PVC and PROP pipes. So this is a PVC pipe, the longer one. Yeah, that's a PROP pipe, the ones that have nuts in them. So PVC is widely used for cold water due to its affordability and ease of installation. PRO PPRO pipes is used for hot water because of its heat resistance and durability. Both materials resist corrosion and provide smooth internal flow. Choosing between them depends on temperature requirements and system design. So if you're looking at if your hot water is going to pass through system, go for PPRO. But if it's cold water, go for PVC. So let's look at governance pipe and proper copper pipes. This is a copper pipe. That's the governance pipe. Governance steels offer strength but is prone to internal corrosion over time. That is rusting. Um, Copper provides excellent durability and hygiene but comes at a higher cost. These materials are typically used in specific applications rather than general installations. Understanding when to use each materials ensure long-lasting plumbing systems. Let's look at hot water systems. Hot water systems provide comfort and functionality in modern buildings. Options include instant heaters, solar systems, and storage tank heaters. Each system has different installation requirements and operating costs. Selecting the right system depends on budget, climate, and user demand. Instant and solar heaters. Instant heaters provide continuous hot water but require high electric capacity. Solar heaters offer energy savings by using sunlight but depend on weather conditions. Both systems have advantages and limitations that must be considered. Proper installations ensure safety and efficiency in operations. Now, storage water heaters. Storage water heaters maintain a reserve of hot water for immediate use. They are simple to install and suitable for consistent demand. However, they consume energy continuously to maintain temperature. The proper installation of safety valves and connections is essential for safe use. Concealed leak detection. How do you detect a concealed leak? Detecting leaks in hidden pipes requires systematic investigation and specialized tools. Signs to look out for includes water stains, mold growth, increased water bills. Techniques such as pressure testing, acoustic detection, and thermal imaging are used. Accurate detection minimizes damage and reduces repair cost. Repairing concealed leaks involve exposing the pipe, identifying the material, applying the correct repair method. Each pipe requires a specific repair approach that ensures durability. Testing before closing the walls is critical to confirm the repair. Preventive practices reduce the likelihood of future leaks. By way of conclusion, this module has developed advanced skills in water supply systems, design and installation. You can now understand how to select tanks, pumps, and pipe materials effectively. You can also recommend suitable hot water systems and diagnose concealed leaks. These capabilities position you as a high level pumping professional ready for complex projects. See you in module 6.